Welcome to an introductory lesson on trigonometry. Today we'll look at just basic right-angled trigonometry. For many of us this might be review, but let's see how we do. First of all, if you're using our graphing calculator, make sure you're in degree mode. Let me show you how to do that. So if you have the calculator here, you've turned it on, press mode, and in mode right here you'll see radian or degree. Often the calculator is in radian mode, so make sure you go over to degree, press enter, and then second quit will get you back to your main screen. Again, no matter what calculator you're using, make sure you are in degree mode. First of all, what is trigonometry? Trigonometry is the study of how the sides and angles of a triangle are related to each other. Trigonometry comes from the Greek words that mean triangle, measurement. Let's begin with the basics. In this triangle, these are called the legs. This is a right triangle because we see a right angle. Across from the right angle, the diagonal side is called the hypotenuse. The legs have specific names. This is the hypotenuse again. When we look at this angle, for example, in relation to that angle, this side here, the one beside it, is called the adjacent side. And the side across from the angle in question is called the opposite side. These three words are key when working in trigonometry. Looking at this angle, there's the hypotenuse. What is this side? Adjacent. Now that we've changed the angle from this one to this one, in relation to this angle, this is the side that is beside it, so that's adjacent. And then across from it, we have the opposite side. Okay, so which leg is opposite angle B? FH, leg FH. Which leg is adjacent to angle B? BH, that leg there. Which leg is opposite angle F? BH is opposite angle F. Which leg is adjacent to angle F? FH, that leg there. Okay, those are the basics. Now we're going to take some notes. There's a notes page that goes with this video. Let's go to the first bit. On this first part of the page, label each side of each of these triangles with the letters H over A. H for hypotenuse, O for opposite leg, and A for adjacent leg. And the angle of reference is marked with a dot. Okay, in this triangle here, the red leg is which one? And in this triangle here, the purple leg is which one? Great. Let's check our work. So check all of them if you've done it. Hopefully that went very quickly. And again, the purpose here is just to get you to be very, very quick with picking out the opposite, adjacent, and hypotenuse legs. Okay, trig ratios. This is the next step. We have a basic right triangle. Now we know this is called the opposite side, adjacent, and hypotenuse in relation to this angle. The three trig ratios are your sine ratio. The sine of angle A is the ratio between the opposite side and the hypotenuse. So if you start at this angle, you write sine of that angle, opposite, hypotenuse. Cosine ratio is the ratio from angle A, the ratio of the adjacent side and the hypotenuse. And the tangent ratio is the ratio, again, from angle A of the opposite side over the adjacent side. An easy way to remember this is the acronym Sohcahtoa: sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. And they're all laid out here. Sohcahtoa. That helps many students around the world remember this every year. And it sounds a lot like soaking your toe. Alright, so here in this triangle, using those ratios, what is sine of angle B? Well, I hope you remembered sine is opposite of a hypotenuse. There's your so, and the opposite from B is 6, and the hypotenuse is 10. So sine of angle B is 6 over 10. In this triangle, find tangent of angle X. Tangent is opposite over adjacent, TOA, therefore we have from X opposite over adjacent, 7.5 over 18. Find the cosine of X in this triangle. Well, cosine is adjacent over hypotenuse, ka, and in this triangle, adjacent to X is 2, and the hypotenuse is 3, so 2/3. Again, we're just doing the basics right now. Let's keep going. Look at this triangle, and please solve for side y. But let me help you out with the first one. So first of all, I've looked at angle 42. It's the one I'm given. That is the opposite side from that angle. This is the adjacent side, and this is the hypotenuse. So looking at this, we don't know anything about the adjacent, so we can ignore that. But we do know the hypotenuse, and we are looking for the opposite. So we're looking for the trig ratio that connects opposite and hypotenuse. And if we remember correctly, that's the sine ratio. So sine of 42 is opposite y over hypotenuse 37. This is now just a matter of algebra. We're going to multiply by 37 on both sides. And when we multiply by 37, we get y equals 37 sine 42. Punch that in your calculator, make sure you're in degree mode, and you will see 24.76 is our answer for side y. Now try this one. And check your work. Very similar to the last one. It was a sine ratio because we had opposite over hypotenuse and we were able to solve for x. Okay, another example. Let's look at this one. I'm looking at this, I have this angle, and I have the opposite side, and I need the adjacent side. Hypotenuse is not given, so I'm only thinking about opposite and adjacent here. Okay, well, that is which ratio? Tangent. So hopefully you saw tangent, opposite over adjacent. Tangent of angle 63, 20 over x, and now the x is in the denominator, so it's a little bit different. If we multiply by x on both sides, the x moves there and is gone from here. But then we have x times this, so now we're going to divide by tan 63, which ends up down here. Basically, we've swapped this thing and this thing. These two things through that multiplication and division swap. So algebra brings us to this point. Punch that in your calculator, and you get 10.19. Let's try one like that. Give this one a try. And now check your work. So again, here we have adjacent, hypotenuse. So this was actually cosine adjacent from 21. Hypotenuse, cosine is adjacent over hypotenuse, 3 over x. Don't forget, when we have that there and the x in the denominator, we swap them like this, and our answer is 3.21. One last example. This time notice the angle is the unknown. In the last two problems we had x or y along the sides, but now we're looking at an unknown angle. We can still use a trig ratio to solve this. So we're going to set up a cosine here. Why? Because we have from this angle x the adjacent side and the hypotenuse. So cosine of x equals adjacent side over hypotenuse. Now the angle is unknown. To deal with that, we do what is called an inverse trig ratio. So anytime we need the angle, we can say the angle equals, and then this -1 means the inverse. So the inverse trig function of 8 over 13. This can be done on your calculator like this. Let's try. So here, so instead of punching sine, cosine, or tangent, I'm going to do second and then cosine, and notice it's inverse. Then I'll do 8 divided by 13. Enter. 52 degrees. Let's check here. 52 degrees. There we are. Okay. So please try this one. Here we go. In this one we had the adjacent side and the opposite side. That is tangent. Opposite over adjacent. So, and the angle is unknown. Set up the inverse trig ratio, solve, and you have 38.7 degrees. Hope you got that. Let's take a look at a couple more things. This is a big idea. Notice there's these two triangles. They both have the same angles, 27, 90, 63, but they're different sizes. These are called similar triangles. Basically, one is a bigger version of the other. If we set up a tangent here, it's opposite, it's tangent of C, opposite over adjacent, 6 over 12, and that gives us 0.5. If we set up a tangent of angle C here, even though it's a bigger triangle, we can still find that we have 12 over 24, which is also 0.5. So it's important to note that tangent of 27, because that's what C is in both these cases, will always be 0.5. It seems strange at first, but it's always true. No matter how big this triangle gets, the tangent of 27 degrees will always be 0.5. And that's the same for any angle. So in other words, sine, cosine, or tangent of any angle will always give us the same value. Doesn't matter what the triangle looks like, because the ratios remain in the same proportion. That's a big idea. Alright, tangent of 27, if you punch down your calculator, should give us the same thing. Let's double check. Tangent of 27. Well, hopefully it's 0.5. There it is, 0.5. Alright, there was a little rounding in the diagram we had, but there it is, 0.5. Excellent. Alright, let's do a couple word problems. Here we have Batman, Superman. Of course, they always meet on other opposite sides of a gorge. So here's the problem. They're directly across from each other. On this gorge, an observer stands 100 feet away from Batman. So let's sketch this out. Here's Batman. Here's Superman directly across from him in the gorge. And an observer stands 100 feet away from Batman. Here's the observer 100 feet away from Batman. Looks directly across the gorge, so the observer is looking directly across. Now the observer has to rotate 58 degrees in order to look directly at Superman. So imagine this person looking straight across. They have to turn their head and then they can look at Superman. So there's 58 degrees. And the question is, how wide is the gorge? So see if you can do this using the information we have. Okay, hopefully you're able to come up with this. If this is 58 degrees, and here's the width of the gorge, x, across from Batman to Superman, and these two angles make 90, this must be 32. Now we have a right triangle, we can use trig. And in this case, we're going to use tangent, because we have opposite over adjacent. So tangent of 32 is opposite over adjacent, multiplied by 100, and we can find out the width of the gorge is that value there. Alright, simple triangle problem. Maybe reading words and making a diagram is tricky, but we'll do more of that coming up. Next problem, we're going to India. In India, there's this amazing tower called the Qutb Minar near New Delhi. Beautiful, amazing, exquisite work on this tower. Look at that, amazing. Okay, question number 1. Actually, take a look, see if you can answer question A. Try it now. Okay, so question A. We were given that there's this person here, they look up at 58 degrees to the top of the tower, and that you are standing 15 meters behind that person, and I think it was given that they're 45 meters from the tower. And it said, what's the height of the tower? Well, we have this right triangle here. We can set up a tan ratio. So tangent of 58 degrees, opposite over adjacent, so h, the height of the tower, over 45 meters here. And solving that, h equals 45 times that, and we have a height of 72. That's a pretty tall tower. Actually, that's incredible how tall it is. Now, second question said, you look up at the top of the tower, and you had an injury, and if you bend your head more than 50 degrees, you will scream in pain. So let's see if this angle is 50 degrees. Can you set up a trig ratio to solve that angle? Here we go. So now we're doing another tangent. Tangent of this unknown angle x, opposite, which we just solved here in this triangle to be 72. So we know that's 72. Opposite 72. Adjacent here, this entire side is now your adjacent because we're looking at this full triangle. So 60. Remember to use inverse trigonometry there. Inverse trig ratio. Solve that. 50.2 degrees. Oh wow, that is crazy. You had to tilt your head more than 50 degrees. You are screaming in pain. Ouch. Alright, there's some basic trig problems to try. Find those, practice those. However, if you feel comfortable with this, move on to the next video.